Beta, yesterday we were studying about the triangles, chapter 6 NCERT. We covered many topics related to similarity of polygons and also we done theorem BPT, basic proportionality theorem, right? That is theorem 6.1. We also covered the exercise 6.1 yesterday, and we covered this theorem 6.1. If a line is drawn parallel to one side of a triangle, intersect other two sides in the distinct points, the other two sides are divided in the same ratio, right? So we covered this theorem yesterday. Today we will cover theorem 6.2, right? Theorem 6.2 is if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. You can also say this one is the converse of theorem 6.1. In theorem 6.1 we have, if a line is parallel to one of the side of a triangle, then it divides other two sides in the equal ratio. Same ratio means equal ratio. Okay beta? P, Q, R, S, T. In theorem 6.1, given was this line L is parallel QR, right? And we proved PS upon SQ is equals to PT upon TR, right? We proved these things and this was given, right? But in this theorem it is given that it is a different theorem. It is the converse of the theorem 6.1. It is given that PS given is PS upon SQ is equals to PT upon TR. It is given. This is given, and we have to prove. We need to prove L is parallel QR. Now you can see what is given here we have to prove here, and what we have proved here it is given here. So we can say this theorem is converse of the theorem 6.1. So proof, let's see how we will prove. Now it is given that AD upon DB is equals to AE upon EC. What is given? Given that AD upon DB is equals to AE upon EC. It is given. It's given. This one is given. AD upon DB is equals to AE upon EC. And what requires to prove? Required to prove is required to prove is कि DE is parallel to BC. Okay, this line will parallel to this line. Now here we will prove it by the method of contradiction, or you can say the method of assumption. Okay, suppose first assume, you can say the method is assuming method. First assume कि let D is not parallel to BC. What we will assume? D is not parallel to BC. Means we are supposing कि D is not parallel. If D is not parallel to BC, then there must be a line that will be the parallel to BC. Let's say कि DE dash, this line, DE dash, this line is parallel to BC. So what we assume? We assume कि DE dash is parallel to BC. We assume that कि DE dash is parallel to BC. So here DE, as we have assumed that कि DE dash is parallel to BC, then by Thales theorem, we can write this one. Look at this. We can write this one. AD upon DB is equals to AE dash upon E dash C by BPT. It has written here Y. We can write by BPT. Okay. So by BPT, AD upon DB is equals to E dash upon E dash C. And now it is given that कि AE upon EC is also equals to AE upon E dash C. Why? Because better look at here, this one. AD upon DB is equals to this one, and AD upon EC, AD upon DB is also equals to this one. See here, AD upon DB is equals to this, and AD upon DB is also equals to this. So by watching these two equations, we can say कि AE upon EC is equals to AE dash upon E dash C. We can say, right? Suppose this is the equation 1 and this one is equation 2. So from first and second, we can write here from first and second. This one is the equation first and this one is equation 2. So by first and second we can say that AE upon EC is equals to AE upon E dash. So now you can, by seeing these two equations, what you conclude? You conclude कि AE upon EC is also equals to AD upon BD, and AE dash upon E dash C is also equals to AD upon BD. That directly implies that कि E and E dash must coincide. Are you getting my point? This part upon this part is equals to this part upon this part, and it is saying that this part and this part is also equals to this part upon this part. That directly implies that this part, this point and this point must coincide to each other. So E and E dash coincide each other. That means that if DE dash is parallel to BC, this means that DE is also parallel to BC, because these and these are the same line, na? Because this point is common, already common, and these are coinciding. That means कि DE dash and DE both are the same lines. Both are the same lines. So DE dash, as we have assumed कि DE dash is parallel BC, that means कि D is also parallel BC.
So we can say that DE dash is parallel to DE.
No, beta, DE dash is not parallel to DE. DE dash and DE are the same line. They are coinciding each other.
Same line and coinciding each other. So equal also equal.
It is not necessarily that they are equal, because the length of the two lines may be differ, but they are coinciding each other. Here we need to explain, we need to say, only meaning is that कि DE is parallel to BC. Why? Because we have assumed that DE dash is parallel to BC and E dash and E are coinciding. That's why D is also parallel to BC. Okay? Here it is given that, no beta? You can see here it is given that it has written here. Ki adding first to both sides of above, you can see that E and E dash must coincide. Okay? So here there are some examples, and then exercise. Let's move to the exercise. Exercise 6.2. In the figure 16.17, first, this one. D is parallel BC, find EC. It is given that D is parallel BC and we have to find EC, this length, this length, this length. This length, okay? We have to find EC. So here it is given that D is parallel BC, and recently we learned two theorems about if in a triangle a line is parallel to one side, then what? Then it divides other two sides in the same ratio. So we relate it here. Here AD upon DB equals to AE upon EC. How? Aman?
Yes.
How?
By BPT.
By BPT. Right?
Yes.
So you can say all the measures are given instead of EC, right? You can solve it, na? AD is 1.5, this one is 3, this one is 1, and you have to find EC. By transposing this you can find it. EC is equals to 2, 3 upon 1.5, that is equals to 2 centimeter. Okay? So let's move to the another, this one. In this one, what we have to find? Find EC in first and AD in second. AD in second. We have to find AD here, this side. AD. So you can find this also by similar theorem, है ना? Here AD upon dV is equals to AE upon EC by BPT. By putting all the values you can find it, right? I'm not going to solve this one, you will solve it by yourself. So better, let's move to the question number 2. It is saying that E and F are points on the side PQ and PR respectively of triangle PQR. There is no figure of this question. So here E and F are points on the side PQ and PR of respectively of triangle PQR. For each the following case state whether EF is parallel QR. So first of all we will draw a triangle. Okay. So here we have a triangle. Its name is PQR. PQR. Okay. E and F. E is on the side PQ. E is here, this, and F is on this side. Join EF. E and F are points on the side PQ and PR. For each of the following case state whether EF is parallel QR or not. We have to check for all these cases whether EF is parallel QR or not. First case is PE is 3.9. This one is 3.9. EQ 3. This one is 3. PF 3.6. 3.6. And FR 2.4. So remember the converse of theorem 6.1, converse of BPT. What is converse of BPT? It says if the ratio, if there is a line dividing two sides of a triangle, and if the ratio of this and this is equals to the ratio of this and this, then this line is parallel to this. Here we have to check if this line is parallel to this or not. And for that we will check whether this upon this is equals to this upon this or not. If this upon this is equals to this upon this, then by theorem of converse of BPT we can say that this line is parallel to this. Right? So let's check. 3.9 upon 3. By simplifying it, EP upon EQ is equals to 3.9 upon 3. That will be equals to 1.3 upon 1, right? And by this side, PF upon FR is equals to 3.6 upon 2.4, that will be equals to 1.2 upon 0.8. So they are not equal in the ratio, right?
Yes.
This ratio and this ratio is not equal. The another way to check whether these ratios are equal or not, you can cross multiply these two. Okay. Suppose if you have a doubt, sir, how can we check if this ratio is equal to this ratio or not? How we will decide it? For that, put this upon this equals to this upon this and cross multiply them like this. 3.9 upon 3 and other one is 3.6 upon 2.4. Now cross multiply it means multiply this one by this and multiply this side, this one by this. If both are equal, then the ratios are equal. Okay. So for first case, we can say that EF is not parallel, QR not parallel. For first case, not parallel. Okay, beta. Let's move to the second case. Okay.
Remaining question I can solve it. Remaining question I can solve it.
Okay, beta. Okay. So let's move to the second question, that is PE4 centimeter, QE is 4.5 centimeter and PF 8 and RF 9. So you can see all the measurements are given. PE4, EQ 4.5, PF is 8 and this one is 9. So same as we have done the first one, you can check whether EF is parallel QR or not, right beta? Similarly, if this upon this will be equal to this upon this, then in that case they are parallel or not. Clearly we can see it is, the ratios are equal. Here PE upon EQ is equals to 4 upon 4.5. Okay, and PF upon FR is equals to 8 upon 9. So by simply multiplying it, 4 upon 4.5 comma 8 upon 9, cross multiply them, what we will get? 9 for the 36 and 8 multiplied by 4.5 will also equals to 36. Means this multiply this is equals to this multiply by this. So we can say they are parallel. In this case, parallel. This one is parallel to this. Okay. Okay, let's move to the question, third part of the question 2. 1.28 PR,
Not PF, PQ.
sorry, PQ. PQ means this whole 1.28. Okay, and PR is 2.56. PR 2.56. Okay. P is 0.18. P is 0.18 and PF is 0.36. PF 0.36. So beta we have to check whether EF is parallel QR or not. In these two cases, the measurement of this part and this part as well as this part and this part was given but here the measurement of these and these are not given, but the whole PQ is given. The length of PQ is here given. When you subtract the value of PE from the PQ, you will get the value of EQ. Means by subtracting 0.18 from 1.28, you will get the value of this, that is equals to 1.1, right? QE will be equals to 1.1. How? QE is minus 2. QE is equals to 1.28 minus 0.18, right? So 0.1, right?
Yes.
That will be equals to 1.1 centimeter, 10 or 1.1. Similarly, you can find FR by subtracting TF from PR, right beta? How we will get F? FR will equals to PR minus PF. That will be equals to 2.56 minus 0.36. What it comes? 2.2. 2.2 centimeter. Okay. Then now you can check, as you check these two ones, you can check it whether EF is parallel to QR or not. Okay. Check it. Okay beta. So let's move to the question number 3rd. Okay. Question number 3rd. Figure is given here. It is given that LM is parallel BC. LM is parallel BC and LN is also parallel CD, yeah DC. Okay. LN is parallel CD. And what we have to prove? We have to prove AM upon AB is equals to AN upon AD. AM upon AB is equals to AN upon AD. While I was proving BPT theorem, at that time I explained you कि if you proved in triangle, suppose in this triangle only, if there is a triangle, let me draw. If there is a triangle PQR and there is a line intersecting it at other two sides at 2 points EF, if you proved कि PF upon EQ is equals to PE, right? If you proved कि PE upon EQ is equals to PF upon FR, that is the BPT theorem also. If you have proved it, already proved it, then you can write कि PE upon, it implies that कि PE upon PQ will equals to PF upon PR. In that class I explained you this, right? If this one is proved, means it is given, you can write this one like this. If someone asks how, add +1 and +1 both sides, you will get this one. Okay? So if you don't have to show कि I have add 1 both side, you can directly put the sign of implies that and write this one. Okay? So similarly beta, here what it is asking that we have to prove कि AM upon AB, similarly like this कि PE upon PQ. So we have to prove कि AM upon AB equals to AN upon AD. Now, if you are success to prove that AM upon BM, MB, AM upon BM is equals to AN upon DN, then you can write कि AM upon AB is equals to AN upon DN, like this, है ना, Aman? So look at here. In triangle ABC, in triangle ABC, you can see LM is parallel BC. You can write na कि AM upon AL is equals to BM upon CL by BPT. Any doubt?
AM upon AL, sir.
Sorry, 1 minute. AM upon BM. AM upon BM, right? AM upon BM. I have write the whole equation wrong here. By BPT. AM upon BM is equals to AL upon CL. AL upon CL by BPT. Make this one as equation first. Now in triangle ADC, in triangle ADC, LN parallel CD. So we can write AN upon DN is equals to AL upon CL. Make this one second. By observing equation first and second, you can see AM upon BM is equals to AL upon CL, as well as AN upon DA is equals to AL upon CL. So from first and second, from first and second, from first and second, we can write कि AM upon BM is equals to AN upon DN, right? Because things which are equal to the same things are equal to each other. So we can write AM upon BM is equals to AN upon DN. DN, right? And by adding 1 on both sides, you can convert it in AM upon AB is equals to AN upon AD. Okay? If you add 1 both sides, you will get it. Any doubt? Okay. So by adding 1 both sides of this equation, you will get AB upon AM, right? You will get by adding plus 1 to both sides of this equation, we will get AB upon AM, na? Not AM.
AM is equal to AB.
1 minute, beta. By adding 1, what we are getting, we are solving it, okay? By adding, BM will be the LCM there. He will get BM plus AM. BM plus AM. What we have to prove there? That is AM upon AB, right? So first we have to reciprocate it. Then we have to add 1. Okay? First we have to reciprocate it, then add 1. Then you will get only the AM upon BM. So beta, first reciprocate it, then add 1, then you will get that. That will be BM upon AM is equals to DN upon AN. And now add 1 to both sides, plus 1, what we will get? AM will be the LCM there, and we will get AM plus BM. AM plus BM will be equals to, another side AN will be the LCM, and we will get an plus dn, an plus dn. So you can see the am plus bm, that is ab upon am, and an plus dn, that will be equals to ad upon an. But we have to prove am upon ab, then we will reciprocate it again. So we will get am upon ab is equals to an upon ad. Okay beta.